All right, here we're looking at section 6.3. And like always, we start with our learning targets. So today we're really defining and evaluating logarithms and what they really mean, because this is kind of a weird thing to think about what it really means. And then we're going to be looking at some inverse properties of logarithms. Really, we're just going to be kind of graphing today and evaluating. So on your next page in your notebook, we're going to be using this page to start with, logarithms. Okay, and we're just going to be filling out some notes in here, and then you have some practice problems to work on inside. Okay, so here's the question that we're going to say for logarithms. That's really just what it is, that we're asking a specific question. So the question, I'm going to start with that, is what exponent is required to go from a base of b to reach the value of a? So here's what we're seeing when we're dealing with logarithms. I have log base b of a is x. So make sure you get this down, because this is our just general form of a logarithm that we're really going to be using. So again, my question is, what exponent is required to go from a base of b to reach the value of a? That's what this is telling us. This is the exponent that I need to get from b to a. And so we're kind of going back and forth with exponential functions. Remember we talked back in chapter 5 about inverse functions. Well, a logarithm is an inverse function to an exponential function. So let's look at these two different forms. Okay, and here you see I have different colors, and that's really going to help us to understand and keep things separate and easy to follow. So when I have my exponential form, I have my base to my exponent, which gives me an answer. Right? We've seen that many times before. Well, when I have my logarithmic form, I have the log base b, is what we have, of the answer equals the exponent. Okay, so that's kind of the forms that we're going to be living in. And so this is really how we can go back and forth between the two forms. And that's really how we're going to be solving them, is going back and forth between exponential and logarithmic form. So it's really important to kind of understand the pieces of where they go. So I want to go ahead and show you a couple of things. So on the inside, we've got a couple that we're going to actually calculate, and then you're going to convert some between log and exponential for me. Okay? Because the more we do this, the more comfortable we get with that. So here, for this first one, the question I'm asking is, what exponent do I need to get from 4 to get to 64? Okay, so that's our kind of big, what power of 4 gives you 64? Well, I know that 4 cubed is 64. So this answer, when I finish my log, is going to be 3. Okay, so here I have both forms, just like that. I've gone ahead and I said 4 to the third power equals 64. And we can, if you see how my pen did that kind of a loop, you can do that as well. 4 to the third power equals 64. We're always going to do that. So even here, 6 to the what power gives us 216. So this is going to just take some trial and error. Well, I know it's not 6 to the first power, and I know it's not 6 to the second power, so try another one. See if that works out. See if you can have your calculator help you kind of 6 to the third, 6 to the fourth, 6 to the what gives me 216. Here you'll see we also have some fractions. So remember our properties of exponents, where if I have a negative exponent, it moves the whole thing into the denominator. So again, I ask myself, 3 to the what exponent gives me this kind of a fraction, this 1 over 243. Well, so I know that this is going to be a negative value over here, since I have this in the denominator. So we can just kind of use this to help us understand. So even over here when I'm converting between exponential and log form. Okay, so here is my base, so it would be log base 9 of x equals y. So again, I can follow around. Log base b, so log base 9 of x equals y. That's how we can go ahead and write that. And I'll go ahead and write this one down for you. So log base 9 of x equals y. Okay, so the exponent that is needed to get from 9 to x. That's how we can kind of read these things. So now in here, I want you to take a few minutes to practice these back and forth, because the more we do this, the more comfortable we're going to get at them. Okay, so on your next page, we just have a couple more things that we need to look at in this section. So there are a couple of different logarithms that we see often. The first one is the common log. Okay, so the common log is one with a base 10. And we use base 10 a lot in math and in science. So this is kind of our common log. So this is just log base 10 of x. And so really whenever we have this base 10, since this is our common log, we don't have to write that, just to kind of simplify. So whenever you see log x, like if you look on your calculator, you'll see something that looks like this. This just has a base of 10. Okay, that's kind of our important piece. So then the other one that we deal with often is called our natural log. And here we're using a base of e, right? And so we talked about e in our last section. So here we have log base e of x. So instead of having to write it like this and just get lost with letters, the way we really write it is ln x. So this just means the natural log of x. So we're really using this base e here when we're dealing with our natural log. Okay? So most calculators, and I know Desmos does this too, have these two to use as well. So we're using the just common log with base 10, and then our natural log with base e. Okay, so this is kind of what our calculators really look at. Okay, so the other thing we want to look at is we want to look at graphing these functions. So we're going to use this little purple quarter sheet of paper, and I'm going to go ahead and glue it in so it doesn't go anywhere while I'm taking my notes. Okay, so we're looking at our parent functions. And in our next, I believe it's our next chapter, we're going to really look at the transformations. So first we want to start with just what our parent functions look like. Okay, and here you do need a couple of different colors to really kind of see. Okay, so here I'm looking at when b is greater than 1. So I've got log base b of x when b is greater than 1. Okay, so what that looks like is it looks something like that. It does cross, and I didn't do a very good job right here, at 1, 0. So we're going to make a little note of that. So here is where log base b of x. Okay, so you can see that this is a mirror. Remember when we talked about inverse functions of our exponential growth equation, which was b to the x. So these two are inverse functions you can see by this graph. Okay, so now let's look at when b is at fraction. So when b is between 0 and 1. So when we talked about our exponential functions, we had that same thing. We had our exponential decay, which looked like this. So again, we're dealing with our inverse functions, which are reflections over the line y equals x. So my new function again crosses at 1, 0. And it looks something like this. So I'm going to go ahead and label these. So again, we've got a b to the negative x is what we looked at before. So here's the red one that we're really looking at, is when my b is that fraction. So log base b to the x. Okay, so I'm dealing with that. So from here, I want you to look at what the domain and range have done and what those really look like. So when we looked at our exponential functions, our domain was all real numbers. Well, here now, our range is going to be all real numbers. And our asymptotes have changed from the x-axis, and they are now the y-axis. So since we're dealing with those inverses, we can kind of use that information to help us as well. Okay, so now we've gone through everything. We've looked at our common logs and our natural logs. The biggest thing is being able to convert back and forth. So with this page, definitely have this page out with you while you're doing your homework and your practice, because you're going to be going back and forth and back and forth and back and forth, just so you can get that practice. Because when we start solving these equations, this is how we're going to be doing it. So make sure that you go through and actually fill these out. This is one thing I'm going to definitely be looking for when you when I check your notebooks before we take our test, or I'll check them anytime between now and then as well to make sure you're doing it correctly. So as always, come find me or come email me or see me whenever you get stuck or have questions.